All right, so a plant nursery is growing a tree that is 3 feet tall and grows at an average rate of 1 foot per year. And another tree at the nursery is 4 feet tall and grows at an average rate of zero point 0.5 or 1/2 foot per year. After how many years will the trees be the same height? So what I've done here is I put the time. Time is typically the independent variable along the x-axis, and that's in years because it's saying it's doing this thing 1 foot per year. And the plant's height, they're giving it to us in feet, and it's growing, it's increasing per feet, at some number of feet per year, 1 foot per year, 1/2 a foot per year. So that's the scale that I put on the y-axis, plant height in feet. And you'll notice also that I chose for the plant height. Here I have a scale of every 4 boxes is 2 feet. So we've got 1/2 a foot, 1 foot, 1.5 feet, 2 feet. I wanted to do a scale of 1/2 a foot for each box because we're gonna have to increase by 1/2 a foot for this second one. And this, keeping with the same scale on this side, you can see that this is helpful for the number of years. So let's write the equations and then we'll graph them. So we say the height for plant, the first one, is equal to, let's see, it starts out at 3 feet tall. So that's going to be +3 at the end. And it grows at 1 foot per year. So we say the time in years, I'll call that t, time in years. It's really got a coefficient of 1, right? 1 per year. So we don't write 1t, we just write t. So we have the height equals t plus 3. And for the second one, we've got height equaling. This one starts at 4 feet tall, so we're going to have a +4 at the end. And the t is going to be the number of years, and how much is it growing for each year? Well, it's increasing by 1/2 of a foot, so I'm going to put 0.5, the amount that it increases per year. Okay, so that's what we're going to graph. Give me a second and I'll plot those two. And I'll plot the first one in red so you can see it differentiated from this one in. Okay, so you can see that we've got here our y-intercept of 3. That's what the height is when 0 years have gone by. And after 1 year, notice that if you follow the units on the bottom, that's 1 year right there. Okay, so you follow that straight up, and you get 1 more foot. We've gone from 3 to 4. 1 more year, 2 boxes goes 4 to 5. Another year goes from 5 to 6. Okay, and for the second equation in blue, you can see that the intercept is 4. And every time we are going to increase it a year, we're going to rise by 1/2 of a unit. So after 1 year right there, we've got that unit. After another year, we've got right there. After another year, we've got right there. Another year, we've got there. Another year there. So I'm going to draw. Okay, so then after how many years will the trees be the same height? We can see that they're crossing here at 2, 5. So I would write, I'm going to just write it in, 2, 5, and then I'm going to type the words. After how many years will the trees be the same height? After 2 years, the trees will be the same height. And it didn't ask for what is the height, but we'll. So after 2 years, the trees will be 5 feet tall. That's how you do it.